The second special feature, important feature we're going to talk about with rational functions are points of discontinuity, which might be referred to as holes. And if you take a look at these two examples that I have here, the one on the left kind of looks like some of the examples that you've seen from the first couple videos, but there's an obvious point of removal. You can see right here where it's almost we took that one specific point and took it off the graph. The example on the right is a linear function, and again you can see there was one point, in this case at negative 1, 1, that was removed from the function itself. And we'll talk about how and when those occur. So when they occur, like the vertical asymptotes, they occur when the inputs, at the inputs that are not in your domain, the function's domain. But unlike vertical asymptotes, where you just need to find where the denominator is 0, there's a second stipulation to a point of discontinuity, and that is when common factors from the numerator and denominator simplify out. So how you find these holes is you need to factor the function, factor the numerator and the denominator, and see if any of the factors cancel out. If they cancel out, then there's going to be a hole at that x value. So if we look at this example, it says identify the points of discontinuity and vertical asymptotes. So we always want to start with factoring. So if I were to factor this, my numerator I still have x minus 1. But in my denominator I have, if I factor this, it would be x plus 3, x minus 1. So you can see that these x minus 1s simplify out, and I'm actually left with this new function that is 1 over x plus 3. Now if you were to graph this function, it would look as if you were graphing f of x equals 1 over x plus 3. If you were to plug 1 over x plus 3 into your calculator, or if you were to plug in your original function into your calculator, you would see the same graph which is shown here. We would see that they have that vertical asymptote at about negative 3. You can draw that in. However, we do know that this denominator, we did originally have an x minus 1 and an x plus 3 in the denominator. So, originally, we would not be able to plug in 1 in for x here. That would result in the denominator and the numerator, in fact, being 0. So when things simplify out, like we saw in the previous slide, instead of a vertical asymptote at that x value, it's going to be a hole. So if you were to go over to 1, there should be a hole right there instead of a point for the graph. And it would look something like this. You can see the vertical asymptote here, and then you can see our hole at x equals 1. Vertical asymptote at x equals negative 3. And again, to get the graph, you can always plug the equation into your graphing calculator, go to your table, and get values to plot. If we take a look at this one, identify the points of discontinuity. So right away you might think that we have a vertical asymptote at x equals 3. There's clearly a domain error there. We're not allowed to plug in 3. It would make our denominator 0. But if we do a little bit of algebra and factor our numerator, we see that we have common factors of x minus 3 and x plus 2 in our numerator and denominator. So that would simplify out, and what the graph would look like is just x plus 2, which is a line, right? Mx plus b, where we have a slope of 1 and a y-intercept of 2. So if I were to do this, we have a y-intercept, as we saw, we'll factor this again, ended up being x minus 3, x plus 2 over x minus 3. Those simplified out, and we were left with x plus 2. So we would have a y-intercept of 2, and we'd have a slope of 1. So we'd go up 1 over 1, just like this. And we'd end up graphing a line so we would have a line that kind of looked something like that. However, we know that the point x equals 3 is not in our domain, well, not a point, but the value x equals 3 is not in our domain. So if we go to our graph where x is equal to 3, we're up here, we would not have a point at, in this case, 3, 5. We would put in a hole. And your function would look something like this.